Hi folks, today we're going to continue with factoring, but we're also going to be setting things equal to zero and finding solutions or finding zeros, finding roots. Okay, these are things that we've done in the past. Think back to the quadratic equations where we were finding the zeros. This is really no different. Again, it's just on a little bit bigger scale. So we want to factor and we want to set equal to zero to solve. So our factoring rules are no different than they were in the previous lesson. So we want to first take a look at our coefficients. They're all divisible by a 4, and then we can take an x out. So now, what's left? So we'd have an x to the 4th minus 10x squared plus 9. So we want to take that further, and we can. So minus plus is automatically minus minus. The x to the 4th breaks up into x squared and x squared. And then that 9 is either 9 and 1 or 3 and 3. And in this case, the 9 and the 1, or 1 and 9, will give us that middle term of 10. At this point, there's two different ways you could go on this. You could either treat this as difference of two squares and keep factoring, same thing with this, or you could go ahead and set everything equal to 0 and solve. So here we'd have 4x equals 0, x squared minus 1 would equal 0, and x squared minus 9 would equal 0. So here we would divide by 4, x equals 0. Here we could add the 1, so x squared equals 1. And then to finish getting x alone, we would square root. So x equals, and since we're finding x and square rooting, it's plus or minus, and the square root of 1 is 1. So there we have two answers. Here we have an answer, and do the same thing here. We can add that 9. So x squared equals 9. Square root to finish getting x alone. And since we're square rooting, x equals automatically plus or minus, and the square root of 9 is 3. So if you'll notice, we have 1, 2, 3, 4, 5 answers. And that is in direct correlation to the degree. We should have 5 answers. All right, whatever that biggest exponent is, that's how many answers we should expect down here. There are stipulations to that, but that's something you'll learn later on down the road. All right, this next one, in order to factor it, first we want to make sure that it's set equal to 0. So we want to take this 18x to the 3rd and move it over to the other side. So subtract it over. So we have 3x to the 5th minus 18x to the 3rd plus 15x equals 0. So now, the 3, the 18, and the 15, we have a 3 that can come out of all that. So we can go ahead and factor that out, and then we can take an x out of every term. What's left? All right, so we'd have an x to the 4th left, minus 6x to the 2nd, plus 5. And again, we want to see if we can take that further, and in this case, we can factor that further. So 3x times... So the minus plus in our trinomial will give us a minus minus in the binomials. X to the 4th would break up into x squared, and the 5 breaks up into 1 and 5. All right, now, just like before, we can set everything equal to 0, and we can go ahead and solve this. So the 3x equals 0, x squared minus 1 equals 0, and x squared minus 5 equals 0. Set them all equal to 0 and solve. So here, this one pretty simple, x equals 0. Here, we can add the 1 just like before, so x squared equals 1, and then we can square root it, so x would equal plus or minus 1. And here we'd add the 5, And so x squared equals 5. And then we square root. So x equals plus or minus square root 5. So again, the degree of this polynomial is degree 5, so we should have 5 answers. We have 1, 2, 3, 4, 5. All right, here's another 2 examples, but this first one, I'm going to save this one for you to go ahead and do on your own, see if you can figure it out. I will give you the answers for that though. The answers on this one would be x is 0, x is plus or minus root 3, and plus or minus 2. Now, moving over to this one, we want to do the same thing, set it equal to 0, so our first step would be to go ahead and add 6x to the 4th over to the other side. So we'd have 6x to the 4th minus 27x to the 3rd plus 15x squared equals 0. So now, something that we can take out of all 3 terms, the 6, 27, and 15, those will all give us a 3, and the x's, we can take an x squared out. Now, what's left is 2x to the 2nd minus 9x plus 5. Now, if you wanted to, you could go ahead and try and factor this one, but this one does not factor. So a different way for us to go ahead and find zeros would be the quadratic formula. Now, this part, we can go ahead and set that equal to 0. So 3x squared equals 0. I think it's pretty obvious that x is 0. All right. Now, over here, we need to identify A, B, and C and plug in. So x equals opposite B plus or minus the square root b squared minus 4ac all over 2a. So x equals double negative, so it'll be positive 9 plus or minus square root negative 9 squared minus 4 times 2 times 5 all over 2 times 2. So x equals 9 plus or minus the square root. All of this discriminant that's under the square root winds up being 41 all over 4. And since this 41 isn't a perfect square, we can just go ahead and leave it. It's simplified. It's a prime number, so there's nothing we can really do about it. So there's 2 of our answers, 9 plus root 41 over 4 and 9 minus root 41 over 4. Now, we're supposed to get 4 answers out of this because our biggest exponent is a 4. We're supposed to get 4 answers. Keep in mind here we had x squared, 3x squared equals 0. So this technically accounts for 2 of our answers, even though it only looks like we have 1. Here we're going to cover special factoring patterns, and these aren't patterns I expect you to memorize. These are things that you will be given in the event that you need to use them. But if we have something like a cubed plus b cubed, then the factoring will go something like this, where you have a plus b times a squared minus ab plus b squared. So this first example, x cubed plus 64, we need to recognize that that 64 is actually 4 cubed. All right, so now we have that identified. So here's our A and here's our B. So it's just a matter of plugging in right now. So we have A plus B, so x plus 4, times A squared, so A is the same as x, so it'd be x squared, minus A times B, so minus 4 times x, plus B squared, so B is 4, so plus 4 squared, which is 16. And that's done. That's as factored as that's going to get. You're going to want to try to factor that apart further. It doesn't go. That's as good as it's going to get. That's factored. All right, same type of thing on this next one. We need to be able to recognize that 8x cubed is actually 2x quantity cubed, plus 27 is 3 cubed. So this is our A, this is our B. So again, we can just go ahead and plug in A plus B, so 2x plus 3 times. Now, x squared. So right here, A squared, we're going to square 2x. So 2x squared, we square the 2 and we square the x. So this will actually be 4x squared. Minus A times B. So minus A times B. So 2x times 3. So 6x. Plus B squared. B in this case is 3, so 3 squared is 9. And again, that's as factored as that will get. This next one, the sum of 2 cubes, is really no different than the sum of 2 cubes. So difference of 2 cubes here, and the only real difference between the two equations is the shift of a plus and a minus. But how you go about doing it is really no different. So if you want to go ahead and try these on your own, see where you get, we can talk about them in class. Again, these are things that you need to practice. They're going to be used a lot in the upcoming days, so make sure you know what you're doing. Practice, practice, practice. So your assignment, page 357, numbers 31 to 49 odd, and we'll see you in class.